square root of negative numbers. Now since we know root minus 1 is imaginary number, so root of negative numbers we can find here. Suppose root of minus 9, so this we can write as 9 into minus 1, isn't it? So minus 1, see, I square is minus 1, so 9 into minus 1 we can write I square. Now 9i square we can write 3i square, isn't it? Square root of 9 is 3. Now this square and square root will go out, so answer will be 3i. Similarly we can find for other numbers also. Suppose minus 25, so this we can write 25 into minus 1, that is I square, then 5i square. So answer will be 5i. So we can find square root of negative numbers. Now in real number we know this property holds true. Root of a, root of b, we can write root of a, b, isn't it? Consider the example root 2, root 3. So we can write root 6. Okay. Suppose 3 into root 5, so we can write root 15. So this property holds true in case of real number. Now in some cases for complex number also it is true. In which all cases it is true? Suppose a is 3 and b is minus 3. Okay, so we can write root 3 root minus 3. So root 3 into root, this will give root 3i. So answer will be 3i, isn't it? And using this rule, 3 into 3 will be minus 9, that is also 3i. Okay, so in this case, when any one number is negative, other number is positive. Means suppose a is positive, b is negative. See, in both positive case we saw for real number, and here if one is negative, one is positive, then also this property holds true. But for the case when both are negative, suppose a is minus 1, b is minus 1, so root a root b means what? Root minus 1 root minus 1. So this we know it is I, this is also I. So I square is minus 1. Now consider AB, means minus 1 into minus 1, which is 1, that is 1. Okay, so in this case see, it is not equal. So sometimes we can say for this case where both are negative real numbers, so in this case AB, root AB is cannot be equal to root A into root B. Now for complex number we can prove the identities also. Suppose first one identity, all these identities will be true which are true in case of real number. So z1 square 2z1 z2 plus z2 square. Okay, and this will be z1 minus z2 suppose. So z1 square minus 2z1 z2 plus z2 square. Then z1 plus z2 whole cube also we can write z1 cube plus 3z1 square z2 plus 3z1 z2 square plus z2 cube. Okay, similarly with minus sign also, z1 cube minus 3z1 square z2 plus 3z1 z2 square minus z2 cube. z1 square minus z2 square also, z1 minus z2 and z1 plus z2. Okay, all other identities which are true in case of real number, that are also true in case of complex number. If z belongs to C, that is z be any complex number, then modulus of z or mod z, modulus of z is denoted by mod z, and it is equal to, z is suppose a plus ib. Okay, so it is denoted by a root of a square mod z, and it is equal to root of mod a square plus b square. Okay, this is about modulus. Now about conjugate. Conjugate of complex number z, conjugate of z belongs to C, where z is equal to a plus ib. Conjugate is denoted by z bar. Okay, and it is equal to a minus ib. Okay, change the sign, a plus ib, so a minus ib. Now one more thing we can see here, z is a plus ib, z bar is a minus ib. Suppose find product of these two, what we will get here? A square minus abi plus abi plus minus minus b square I square. So a square, see abi plus abi will go, minus I square is minus 1, minus is already there, so plus b square. So this is what, see we know mod z is square root of a square plus b square. Okay, so mod z square will be a square plus b square, which we got here. So we can write z dot z into z conjugate z bar is equal to mod z square. Okay, this is the relation between modulus and conjugate of complex number. So such more identities or more expression we can have here. Suppose mod of z1 z2, for z1 z2 belongs to complex number. Product of mod of two numbers in product, we can write separately mod z1 into z2. Similarly in division also, this we can write mod z1 by mod z2, provided that mod z2 should not be equal to 0. Okay, this is first, second. Now third one we can write z1 z2 bar. Okay, conjugate of product of two complex number will give product of two conjugate, that is z1 bar into z2 bar. Similarly z1 by z2 whole bar will give z1 bar by z2 bar. z2 bar should not be equal to 0. And then z1 plus minus z2 whole bar, we can write z1 bar plus minus z2 bar. Question number 1 is express each of the complex number in the form of a plus ib. Okay, first question is 5i minus 3 by 5i. Now in this question, this is in multiplication, so 5 we can cancel here. Minus 3i into I is I square. But we know I square is minus 1, so answer is 3. So 3 we can write as 3 plus 0i. So A will be 3, B will be 0. Question 2 is I power 9 plus I power 19. So here I power 9 we can write I power 8 into I, and this we can write 18 into I. Okay, I power 8 means 2 fours and 19 means 2 nines. So minus 1 power 4i minus 1 power 9i. So even power, so this will give positive answer. So 1 into I means I. Here odd power, so this will give minus. Okay. So minus 1 into I is minus I. I minus I is 0. So 0 plus 0 I we can write. So A is 0, B is also 0. In question number 3, I power minus 39. Negative power means we can write in denominator. Okay. So I power 38 into I we can write. And now this 38 we can write I power I square power 19, isn't it? But I square is minus 1. So odd power, so this will give minus answer minus I. Now what we will do, we will remove this I from the denominator. So we can write I into I. Okay. So I divided by minus I square. I square we know it's minus 1. Minus is already there, so answer will be I. I means 0 plus I. So A is 0 and B is 1. Question number 4. So we can open using bracket 21 plus 21i 7i 7i square. I into I 7i square. These two are ith term we can add, so 28i. See, I square is minus 1. So 21 minus 7, both are real part. So we can subtract to get 14 plus 28i. So here A is 14, B is 28. One minus I, from minus we can open the bracket, plus 1 minus 6i. Okay. So see, real part 1 plus 1 2 and imaginary part minus 6 minus 1 means minus 7i. Then question number 6 is 1 by 5, 2 by 5i minus 4 plus 5 by 2i. So here we will open the bracket first, minus 4 minus 5 by 2i. Okay. Then real part 1 by 5 and minus 4 and imaginary part 2 by 5 minus 5 by 2. These two we can subtract to get A and B. So here cross multiplication, so 1 minus 20 by 5 and here also cross multiplication, so 4 minus 25 by 10i. Okay, so minus 19 by 5 and here we will get minus 28 by 10i. So A is minus 19 by 5 and B is minus 21 by 10. For this question, first we will open the bracket and then we will write real part together and imaginary part together. So minus minus plus 4 by 3 minus I. So all the real part together. So 1 by 3 plus 4 by 3 plus 7 by 3 plus 1 by 3 minus, here 1 we can write, isn't it? This is minus I. So 1 and then common I. So 1 by 3, 4 by 3 will be 5 by 3 plus 4 and here 7 by 3 plus 1 by 3 means 8 by 3 minus 1. Now cross multiplication we can do, 17 by 3 and here 5 by 3i. So A is 17 by 3, B is 5 by 3. One minus I power 4. So we can write this as 1 minus I power 2 and then square. Okay. So by this we can open using identity. 1 square means 1 minus 2ab means 2I plus b square means I square and then bracket square. So 1 minus 2I. See, this will give I square is minus 1. So plus 1 minus 1 will go minus 2I square. That will give minus 2 square is 4. Okay, I square is I square. Then I square is minus 1 we know. So answer is minus 4. This we can write as 0I. So A is minus 4. B is 0. This question we can open using identity. A cube. Okay. Then 3A square into B. Then 3A into B square plus B cube. Okay. So this is 1 by 27. Here see, both these 3 will go with this 3 square. So answer will be I here. Here this 3 will go 9I square. Here 27I cube. Okay. So 1 by 27 plus I square is minus 1. So minus 9. I cube is minus I. So minus 27I. So now real part we will separate, and here, okay, so this we can cross multiply. 243 divided by 27. See, minus 27 plus I means minus 26I. So minus 242 by 27 minus 26I. So A is minus 242 by 27 and B is minus 26.